Good afternoon, and thank you very much for staying so late. I definitely appreciate your attention and your time, and thank you also to the organizers. This is an absolutely beautiful city and university. This has been fantastic. We've eaten our way through the city, and I can recommend some fantastic places. My talk today is on residue analysis, so don't fall asleep. There's a bit of chemistry, but not bad, I promise. But there's an emerging pattern that I am finding, and it's truly problematic. So I'm going to talk about some of the problems, some of the potential solutions, some of the methods that we might consider, and of course, just wrap it all up, and then we can go for a beer. Wow, that is very dark. Well, this is most unfortunate. Okay, so in general, when we choose ceramics in our projects for analyses, we tend to choose the beautiful, the rare, the exquisite, something truly interesting about them. And this is perhaps not a good idea. It's not representative. It tells us very little. It's one unique case. And this is translating into interpretations that go into broader archaeology, broader interpretations of rituals for the same communities, for the same populations, for the same cultures, and then into common and daily uses. And this is inappropriate. Okay, good. Okay, so I actually found myself squarely in this position, which is that I found tobacco in the little container at the bottom there. And it's 1 point of nicotine. And there are 2 for the Maya in Central America in Mexico. The top one is the Rio Azul vessel, very famous. There was a residue of theobromine, theophylline that were found in 1980 by Jeffrey Hurst. The bottom one was for my dissertation in 2012. 2 points. But now this interpretation is everything that says chocolate in hieroglyphics is interpreted as holding chocolate. Everything that is roughly that vessel shape at the bottom, a flask, is interpreted as holding tobacco. This is not true, at least so far as we don't have empirical evidence to back this up. We have 2 cases. That's it. Okay. Another problem that we have is that we look at these rare and unique artifacts, and then we talk about them as if this is happening in common daily occurrences. This is absolutely not true. If we are looking at the fine china, how can we say then a cooking pot held the same thing? That these rare foods that are acquired by the kings and the queens of great expense that have been traveling for long distances were eaten by the common population. We can't do that. That's too far an extension of that interpretation. Likewise, context. We do a lot of analyses. It's very expensive. It's time consuming, but a lot of analyses from grave goods. Why? Well, they're well protected. And in general, for the Maya, they're encased. This means that they've not been exposed to rain and to weather and to the various creatures that devour the residues. So it's an ideal place to take residues. Unfortunately, it's a burial. It's ritual. This does not translate into the daily behaviors of people, or even to the daily behaviors of the elites. That is an impossible argument to make, and it's becoming truly problematic. Oh, I'm really sorry. It didn't. Okay. So in terms of the residue analysis, we only have at best 17 to 25% success, especially for the tropics. It's much lower than that because the soils themselves, or the rain, or the creatures, or even the time and duration break down the compounds of interest. But the statistics, the way that we're talking about them, this is a rare occurrence. Not something that we should be talking about in that it happens frequently, or these foodstuffs can be identified in large quantities. Our sample is just simply not that big. We also have not cleanly defined deterioration, which samples are not present because it's just not there. Over time, over erosion, it's just simply not there. But also, what we are not capturing in the data is not finding something. So in terms of finding chocolate, there was a lot of analyses done looking for chocolate, but they didn't find it, they didn't record it. And ultimately, for my dissertation, let's see here, let me get to this picture, okay. So the reusable vessel is the beautiful lock top vessel, storage vessel. But there's these cylinders, and they're all over the world, famous museums, and they're talked about as chocolate pods. Why? Because in the hieroglyphics, it actually says, uh, rough translation, this is the drinking vessel for chocolate. So it looks like a cup, should be a cup, says chocolate, therefore has chocolate in it. But the analyses that were done by other projects, they failed to find chocolate. And there are minor notes and some documentation, but that's it. This actually turned out to be incredibly important information. For my dissertation, I analyzed 110 of these, looking for chocolate. There's no chocolate in any of them. It was relevant information to capture. So the money, the expense, the destruction to the samples we had, there are very little residues to work with. If we are going to go through this process, the expense, we need to record everything that we're doing, the methods that failed, the things that we look for that simply were not there, to record all of it. And right now for residue analysis, we're not taking the attention to do such things. I'm really sorry. This is hard for me to see too. I imagine it's probably not much better for you. Okay, so ultimately, it's the patterns that we need to establish. Residue analysis is relatively new. The amount that's being done is not terribly high in numbers. So establishing the patterns is going to have to be both the positive finds and the negative finds to construct the arguments of what people are eating, when they're eating it, and how they're eating it, and where. Okay, so my buddy, the chocolate pot, that's not good. Oh, that's interesting. Okay. It just didn't translate. All right. So one of the solutions that I'm working on, I'm doing another PhD in the chemistry department in the analytical chemistry, is that we need a better way to do residue analysis. I don't know, maybe you have the pleasure of working for a project that is well funded, but at least in the Americas, we're not. Residue analysis is very time consuming. It's expensive. And if you don't have someone that works for you that is a chemist or has the availability to the instruments, it's unlikely that you're going to target much of anything. But there is new technologies that are available, and they just need archaeologists to pay attention. They need archaeologists in chemistry, not chemists working in archaeology. They're going to ask different questions. They're going to see different things. And in this particular case, what I'm working with is Raman spectroscopy. And essentially all it is light. It's non-destructive. It requires no preparation. You don't even need to scrape. And you can reanalyze, but there is absolutely nothing that you're doing to harm the sample. In terms of organics, it's slightly problematic, which is that you have to go from a known to a known. So in order to find, say, corn, you need to have a pure sample of corn to compare the signature with. So in Raman, the light source is shined on the sample, and almost all of it flies off as fluorescence, but 1 out of a million little photons get very excited and they bounce off and they go a different direction. If we measure him, he tells us exactly what he bounced off of. So we have a perfect fingerprint of the compound of interest. So if we had such a technology that using macrofossils and pure samples that we find in the various excavations and build the database of these pure samples, and most museums have Raman available. It's very simple to do. But out of a comparative database, multiple samples from excavation can be run. And right now in development is handheld Raman. So eventually we should be able to take the instrument to the field, and during excavation, you find the vessel, boom. Either it has corn or it doesn't, or it has meat, or it has chocolate, or it doesn't have chocolate, or it has tobacco, but that would give us the numbers to deal with. And it could start creating these patterns that we need for interpretation. Right now, however, what we are doing by extension is to turn chocolate into the availability of all the kings and queens, where we simply do not have that evidence. That is absolutely not backed with anything empirical. Okay, I mentioned that was the most interesting slide of the lot. Okay, so the conclusions, as you can clearly see, are both terribly informative and completely slipped my mind, but it really comes down to that, which is that I found myself editing papers and reviewing papers that were talking about tobacco and tobacco in these flasks. I found the only one. There aren't any other, there's no more data, there's no more information. It's not a pattern, it's a single dot. So the overextension is happening to my own research. And this really kind of caught me in the headlights, which is, of course, I want to crawl through the tombs. Of course, that's where I want to take my samples. Absolutely, I want to play with that particular pot because it's so amazing. But the truth is that we're better to do and apply the residue analysis to the vessels in the common areas, the cooking pots. I'm almost done. Okay. And that one says thank you. And thank you very much for your indulgence and your time. And yeah, if you ask me for my email address, I'll give it to you clearly. It's not there for anybody. But if you have any questions, we can answer them now over beer. Either one, it's fine.